Hello and welcome to this first topic about machine learning algorithms. As you can see in this series, I will be discussing all about machine learning algorithms, and this is the first step for any machine learning engineer to basically understand at a high level what are the machine learning algorithms that are available and what do they represent, and finally how to use them using a tool like Python or R. So in this series, we will be using Python to execute these machine learning algorithms. So let's get started. So first thing is machine learning algorithm classification. So what I meant by that is, at a high level, how would you classify machine learning algorithms? So there are a number of machine learning algorithms that we have it, but first we really need to understand how we need to classify them in a group so that we can better understand the usage of each type of algorithm. So the first type of machine learning algorithm we have is the supervised machine learning. So as the name suggests, supervised is a type of machine learning where some supervision is given to that type of machine learning algorithm, and there are a number of algorithms which is inside the supervised machine learning. The next type that we have is the unsupervised machine learning, and as the name suggests, again it is unsupervised. That means there is no supervision or monitoring, and it's pretty much open-ended, that you have just given a lot of data to the machine learning, a type of particular type of machine learning algorithm, and now the algorithm automatically identifying some sort of patterns or recognition from the data, and then basically doing a task of prediction. Finally, not finally, but this is the second last, semi-supervised machine learning. Semi-supervised machine learning, as the name suggests, is a combination of supervised and unsupervised machine learning. And usually what happens in this case is that, let's say you have a data set on which you need to apply machine learning algorithm, and there is always a target variable that you need to predict. So think about a scenario where this target variable, in many cases it is available, but in some cases it is not available. So what you do is you basically apply the combination of both unsupervised and supervised machine learning and predict the right outcome from the data set. So it's basically a combination, and we will see it in action in later videos. Finally, what we have is the reinforcement machine learning. So idea here is not to do the accurate prediction, but improve the prediction by trial and error. Think about a robot which has been introduced into a real-time situations, and robot is having a predefined set of instruction, but it also have a machine learning algorithm which is observing all the events nearby in the environment, learning from it, sometimes even failing and learning from that failing. So reinforcement learning is, the goal is that you learn by doing mistakes. All right, so first of all, we will see the supervised machine learning. Supervised machine learning, as I mentioned, is a type of machine learning where a supervision or monitoring happened. So what usually happen in cases like this, that data, let's say you have a training data. So what is training data? Training data is something like a sample that is available to you, on which you need to apply the algorithm and do the prediction on the real-time data. So let's say you have a training data, and training data is divided into two parts. The one part is having the target variable. Target variable is a variable which you need to predict. So for example, suppose there is a situation where you want to predict whether a message is a spam or not. So to predict that, we need to first have a series of data points where a message is written, and it's clearly indicated in the next column whether this message is a spam or not. If it is a spam, it will be mentioned as spam, and if it is not, it will be mentioned as not spam or ham. So this is, let's say you have 1000 rows of observations, and then you apply the algorithm to predict whether the 1001 observation that you will get from the real-time SMS or email will be a spam or not. And this is a very popular algorithm if you have observed in your email from the Google. So Google has applied this algorithm, and now even every other email provider has applied this algorithm to identify whether a particular message is a spam or not. So in this, the very first algorithm that we have is a very straightforward linear regression. So linear regression is a type of algorithm where you do the prediction of continuous data. So what it means is, let's say you are in a company, in a sales department, and you need to basically predict what will be the sales in the next month. And what you do, you basically do you draw data on the chart and basically identify whether it shows a positive trend or a negative trend, and based on that trend you forecast the values. Another supervised machine learning we have is the logistic regression. The aim of logistic regression is to basically predict between two classified values. So for example, today whether the rain will happen or not, or there will be a traffic in the on the roads or not, or whether a particular transaction will be a fraud or not, or like I said, whether a particular message will be a spam or not. So it's like a binary classification problems. So logistic regression is used in that case. Then you have decision trees. Again, decision trees are used in both binary classification, which is a logistic regression case, as well as to predict the values. So what it does is, it's based on like a tree has like a lot of branches, and at the node branch, or the branch which is at the last, is basically having either the leaves or the flowers or the fruit. And that's what it has been applied in decision trees, that it divides the data into a lot of different branches, and then finally at the last node you have the outcome about your data set, or the prediction that you want to achieve. And then finally what we have is the random forest algorithm, again used into the prediction of continuous data as well as binary data, like the linear regression or the logistic regression we discussed. It's advanced version of decision tree. As you can see, it's basically a forest. So what it does is, it basically creates thousands of trees, and it learns from each tree, and then basically combined all of this learning, sometimes also called ensembled learning methods, which probably you will hear in the machine learning ecosystem, or the blogs that you will read. So these are some of the examples of machine learning algorithm, and don't worry, this is just a bit of a theory, but we will going to apply all of these in the real-time scenario. The next one is the Naive Bayes. Naive Bayes is a probability-based theorem, and it basically have a concept that you want to know whether the outcome of an event is dependent on another event or not. Very popularly used into situations where these type of scenarios are coming, and we will see it with the help of an example when we will apply for it. Then you have unsupervised machine learning. In unsupervised machine learning, as I mentioned earlier in the second slide, that there is no supervision or no target variable. That means we don't have any learning from the data set. It's like you have been given an open-ended data set. You don't know what the target variable is, what you need to predict. It's just that you need to figure it out, or you need to make some sense out of the data that is being given. A very, very common scenario. For example, if let's say you are in a company and you need to identify the customer segments. Now the customer segments, if you let's say there are thousands of customers, you have to basically profile thousands of customers in a way. If you are going in a manual way, then you have to profile, you have to understand each customer, and then combine it with the different parameters, like what sort of sales they are having, what sorts of products that they are achieving, what sorts of revenue recognition pattern that they have with our company. So to reduce all this and to automate this task of identifying a similar type of customer, like high growth customer, low growth customer, or moderate growth customer, let's say, then what you can do is utilize the unsupervised machine learning, which basically does is what it basically does is it's create a groups of these customers, and then basically gives you an indication about based on the common characteristics that they have shown historically. That's basically the group of customers that they represent. So couple of algorithms that are there is the k-means algorithm, k-means clustering algorithms. What it uses basically a distance based methods for identifying the groups or clusters. You have principal component analysis, which is basically nothing but the dimensionality reduction algorithm. We will see it in action, basically used to reduce the number of parameters into the data set which are not useful for the purpose of machine learning, so that we are only focused on the quality parameters or the quality variables. Then we have scalar vector machine. It's basically a classification algorithm again. So what it does is, based on the parameters, it checks how to best segment the data set so that we have good quality segments which we can then interpret what it really represents. And then finally what we have is the association rules mining. It's basically trying to understand the customer behavior. So for example, in a superstore, if you are going, what they basically observe is what sort of products that you are buying and combination of products that you are buying, so that they can keep the similar products together and have more revenues from you. So a lot of applications are there because as you know, retail is a very big market, and they apply a lot of new approaches every regular interval to identify how they can really increase the revenue with the same set of customers. And then finally what we have is the reinforcement learning. I mentioned on the second slide about it. I don't have any algorithm for you. It's mostly around the deep learning or the neural networks, basically a learning algorithm which is capable of self-learning. And I want to just give you one example about it. So earlier I gave you the example of a robot. A robot is introduced in a normal human condition, and from the trial and error, it is basically learning about the regular environment and improving its algorithm. Now the second type of example can be a video game company, where a video game company is really interested in knowing the type of action you are having against its agent to basically defeat it. So this way, what gaming company is really trying to understand is how they can make their game more challenging by learning from your action, and when you come again into a next game or a new game, you will find a better opponent. In this way, you are also learning, and the gaming company is also learning, and you are then finding how challenging it is becoming, or it's like challenges are going on a next level based on the actions that you are taking. So again, very much used in scenarios like this, reinforcement learning and a bit of advanced learning methodologies that we have, but we will see it with the help of neural networks and other deep learning frameworks that we have, about how we can really utilize this. So that's about a quick theory or quick high level basic understanding I wanted to give you about all the different types of the machine learning algorithms, like supervised, unsupervised, reinforcement, and the generally used algorithms within these groups. So I hope you will find it useful, and I will meet you in the next topic about how we can implement all of these algorithms.